Okay, this is the last part in this little video series about moles, and it's putting the different pieces together to work out calculations involving reacting masses in reactions. Now, these involve multiple steps, 3 steps in each calculation, so a lot of students don't really like them that much or find it slightly intimidating, but we're going to see the method is always the same. And so long as we understand the building blocks of what we've learnt so far, it will make sense. This is a typical question. We're given an equation. So this equation is for silicon tetrachloride reacting with water to make silicon dioxide. I don't know anything about this reaction, but I've been given the equation with the formulas so I can work out the relative formula masses. And then I'm told that 5 grams of silicon tetrachloride reacts. And I'm asked in my question, 3 parts, what mass of water is required to react with it? And what mass of silicon dioxide gets made? And what mass of hydrogen chloride gets made? Okay, so we need to understand the principles we've learnt so far, which is if we know the mass of something, we can know the number of moles of it because they're related to each other. So the mass is to do with how heavy something is. The number of moles is to do with how many particles there are in it. And if we've been told the mass of something, we can work out the relative formula mass using the periodic table, and then we can divide them to work out the number of moles. So that's the first thing we need to be able to do. The other thing we know is that the ratio in a balanced symbol equation tells us the ratio of moles. So, for example, there's no number here, so it means 1. 1 mole of this reacts with 2 moles of this. So the balanced symbol equation tells us the molar ratio, and the word for that sometimes uses stoichiometry. So we're going to use those 2 things that we know to do these calculations. The method is always the same. It involves 3 steps. First of all, we're going to find the number of moles for the substance that we can actually know about. In this case, it's silicon tetrachloride because we're told the mass of it. So we'll work out the number of moles of that. Once we've done that, we just use the equation, we can then use our molar ratio from our balanced symbol equation that we've been given to work out the number of moles of the things we actually want to know about. So for part A, we'll use that to work out the number of moles of water. And then finally, we can actually find what the question is asking us, the mass of what we've been asked about. Okay, so I'm going to go through using the same equation, the 3 parts of this question. So I'm going to use what I've been told about silicon tetrachloride to work out the mass of water that it will react with, the mass of silicon dioxide that it will make, and the mass of hydrogen chloride it will make. Okay, so first thing, I've been told the mass of silicon tetrachloride is 5 grams. The other thing I can work out is the relative formula mass of it. So I can use my periodic table for that. There's 1 silicon atom, which is 28.1. And then there's 4 chlorine atoms, which are 35.5. And that gives us a total relative formula mass of 170.1. Okay, I'm ready to go now. So I'm going to go through these 3 steps for each part. So for part A, working out water. Find the number of moles for the substance you know about, which is silicon tetrachloride. So I'm going to do moles of SiCl4 is the mass divided by the relative formula mass. So in this case, the mass is 5.00, and the relative formula mass we've just worked out is 170.1. I'm showing every step of the working as I go along. That gives me 0.0294. Now, I've slightly rounded that to write it down. It's a really long number on my calculator. I've kept that number on my calculator for the next bit, but I'm just writing it down like that for now. I'm not going to round it as I go along. I'm only going to round it when I get to the very end of the calculation. Okay, now I'm going to use my molar ratio to work out the number of moles of water. So moles of water Now let's look at this molar ratio. 1 mole of this, because there's no number, so that means 1, makes 2 moles of water. So this is a 1 to 2 ratio. I've got to times the number of moles of this by 2 to find the number of moles of this. So I'm going to do this number of moles times by 2, which gives me 0.0588 mole. Just going to put in brackets, that's because it's a 1 to 2 molar ratio. Okay, and now I'm ready to do what the questions actually asked me, the mass of water. Because mass is moles times relative formula mass. I need to know the number of moles of water. I've just worked that out. It's 0.0588. And I need to know the relative formula mass of water, H2O. Now, relative formula mass of water is just going to be there's 2 lots of hydrogen, so 1 times 2, and 1 lot of oxygen, which is 16. So the relative formula mass of water is 18. And if I times those, I get the answer 1.06 is a mass, so the unit is grams. And I've rounded that 3 significant figures because in my question I've been given this mass to 3 significant figures. Alright, I'm going to go through for the next part. The more examples you see, the more you'll understand it, but it's exactly the same 3 steps. So first of all, I want to find the mass of silicon dioxide. I'll find the number of moles of the substance I actually know about, which is the silicon tetrachloride. So the first step is exactly the same. Moles of SiCl4 is 5 divided by 170.1. So I'm just going to write down that number again because I've already done that step. Okay, now I'm going to use my molar ratio again to find the moles of silicon dioxide. So 1 mole of this makes, there's no number here, so that means 1 mole of that. So it's the same number, 1 to 1. It's a 1 to 1 ratio. So therefore, if I've got 0.0294 moles of silicon tetrachloride, I'll have 0.0294 moles of silicon dioxide. Same number of moles because it's a 1 to 1 ratio. So that step was really easy that time. And then the last step is to work out the mass of silicon dioxide, which is the moles times the relative formula mass, as I've written there. So the number of moles of silicon dioxide I've just worked out. It's 0.0294. And then the relative formula mass of silicon dioxide is, there's 1 silicon atom, so that's 28.1. And then there's 2 oxygen atoms, so 2 lots of 16, so 60.1. So that number of moles times 60.1. And that gives me, when I worked it out earlier, 1.77. Again, it's a mass, so the unit is grams. Okay, I'm going to go through one more example then. Same start of the question, 5 grams of silicon tetrachloride, and I'm asked what mass of hydrogen chloride is made. Okay, so the first step again is going to be the same. I need to find the number of moles of the substance I know about, which is silicon tetrachloride. So I'm just going to write that exactly like I did last time. Okay, next step, I'm going to look at the molar ratio again. So the molar ratio between silicon tetrachloride and hydrogen chloride this time. So one of these makes 4 moles of this. So we've got to times it by 4. It's a 1 to 4 ratio. So my moles of HCl is going to be 0.0294 times 4. And that gives me 0.118 mole. Last step, work out the mass of the thing I've actually been asked about. So in the question I'm asked the mass of hydrogen chloride. Mass of HCl. It's the moles times the relative formula mass of HCl. I've just worked out that our number of moles of HCl is 0.118. And the relative formula mass, let's just quickly do that, of HCl is one hydrogen atom, I'm getting all this from the periodic table, and one chlorine atom, 35.5. So if I add those together, 36.5. That's the relative formula mass of hydrogen chloride. So the mass of hydrogen chloride would be the number of moles times 36.5. And I believe that gives us 4.29 grams. Okay, so I've gone through 3 examples there. Hopefully by seeing it 3 times you'll get to grips with the 3 steps that we do for each calculation. Find the number of moles of the thing that we actually know about, that we've been told about in the question. Then use that molar ratio to find out the number of moles of the thing we've been asked about. And then finally use mass is moles times relative formula mass to actually work out the thing that we've been asked. And we can work out the mass of things, all the different reactants and products in the equation.